These are some rules that you need to always check. First thing, on your equation, check for brackets. BODMAS, even BODMAS knows that thing. You need to check for brackets first. You cannot differentiate an equation whilst they are brackets. It's gonna be fucking hard. So always check for brackets, and if there are any brackets, do away with the brackets first. Simplify the equation before you can differentiate. And then number 2, check for x in the denominator. And if there is an x in the denominator, you cannot derive. You need to bring that x into the numerator. So what I mean by that is, say it's number 2. You have an equation like y is equal to say 1 over x. Then you are expected to derive this thing. You check, okay, no brackets. Then number 2, you check, okay, there's an x here. You cannot derive this thing. So what you need to do, you need to bring this x into the numerator. So how we do that, obviously using the laws of the exponents. I told you, you have to know the laws of exponents. Simplifying the equation using the laws of exponents. So if you don't know how to use the laws of exponents, you are in trouble. So we just simplify. Obviously this is 1 times, if we bring this denominator up to multiply to the numerator, it's gonna be the denominator to the negative power that it had. So it was x to the power of 1, so now it's gonna be x to the power of minus 1. Or another example, say y is equal to something like 2 over x squared, and we have an x in the denominator. We need to bring that thing up, so it's gonna be 2. No, it's gonna be y is equal to, so now it's gonna be a multiplication, 2 times x, but into the negative exponent. So this is just 2x minus 2. Then from here you can go ahead and differentiate. But every time you have an x in your denominator, or y if they say it with respect to y, or t if they say it with respect to t, bring that thing up to the numerator every time. And then the third one says no roots in the variables. So number 3, no roots. This is a root, this is the square root, this is a cube root. So what do you know about the square root? It has a 2. So we don't want anything that's going to have a root x or cube root of x plus 1 or whatever in our equation. We don't want this thing. You cannot derive something like this. You need to remove the roots. And no, we do not use, we do not take the squared for both sides. So if we have f of x is, let's say, root x, to remove this thing, we don't just square both sides. No, we don't do that. We don't need to fuck with this side. So what we do is, say f of x is equal to, so obviously this is a square root, it has a 2. So to convert this thing into or just to remove the roots, we take the number that is within this root or outside the root or whatever, I don't know. We take that number and write it as the denominator of the power of the base or whatever x that we had. So we have x under the root, so we say x to the power of something over the number that was here. If it was cubed root, it was going to be 3, but since it's a square root, it's 2, so we take that 2, put it in the denominator of the power, and then the power of x here, which is to the power of 1, it goes to the numerator. So this one is going to be x to the power of half. And then if you have y is equal to cubed root of x, obviously if we are trying to eliminate the root here, we're going to say x, and then it was x to the power of 1, so it's 1, and then the number of the roots here goes underneath, it's 1 over 3. And again, last example here, if we had y is equal to say 4th root of x squared, so obviously it's going to be x, the power of x is 2, it's going to be 2 over the roots, it's 4th roots, so that 4 goes underneath there, x to the power of 2 over 4, obviously that's going to be x to the power of 1 over 2, actually 1 over 2. So this is how we eliminate the roots. So every time we see an equation or formula that has a root, we need to eliminate that root immediately before we can differentiate. So now we're gonna go into some questions so you can see all of this in action. We're gonna do like 8 questions for this, and then we're gonna move on to factorizing cubic function using your blue Casio and the pink ones or whatever.